In April 1923, the aircraft carrier HMS Eagle joined the Royal Navy. Its primary striking power came from the Flycatcher. This was a fighter designed by the Fairey Aviation Company. At first glance, these looked like your run-of-the-mill biplanes, but they made history as the standard fighter for the British Fleet Air Arm. It also holds the distinction of being the first aircraft in the world designed from the outset specifically as a carrier-borne fighter to enter production. For over a decade, these reliable aircraft were deployed on every single aircraft carrier in the Royal Navy. They were also incredibly successful as catapult-launched scouts and floatplane fighters. They operated from the decks of cruisers and battleships. The origins of the Flycatcher trace back to a specification the Air Ministry issued in 1922, calling for a compact deck landing fighter able to operate as a land plane, a float plane, or an amphibian, built specifically to replace the aging Newport Nightjar. By the early 1920s, British naval air power had been severely reduced in the aftermath of the First World War, down to a single spotter reconnaissance squadron, half a torpedo squadron, one fighter flight, one seaplane flight, and one flying boat flight, with HMS Argus standing as the fleet's only carrier in commission. Rebuilding that strength around a dedicated, purpose-built fighter was the entire point of the new specification. The specification allowed either the Armstrong Siddeley Jaguar or the Bristol Jupiter Radial as the power plant, though production aircraft would ultimately settle on the Jaguar. Fairey submitted its design in direct competition with the Parnell Plover, a rival biplane built by the firm Parnell and Company. Although the Plover matched the Flycatcher in raw performance, its all-wood airframe could not match the ruggedness of Fairey's mixed wood and metal construction. The prototype, serial November 163, made its maiden flight from Hamble on November 28, 1922, with Lieutenant Colonel Vincent Nicol at the controls. That first prototype flew with a Jaguar 2 engine, later swapped out for a more powerful Jaguar 4, and the upgraded machine was shown off publicly at the RAF display in 1923. A second prototype was tested as a floatplane at Hamble in May of that year, while a third, built as an amphibian, took to the air that same summer. After completing service trials at Martlesham Heath, the original prototype went aboard the elderly carrier HMS Argus for deck handling trials. Small evaluation batches of 9 Flycatchers and 10 Plovers were ordered so the Fleet Air Arm could judge the two designs side by side. In service use, the Flycatcher proved decisively superior, and Fairey secured every subsequent production contract. The Flycatcher reached its peak in 1930. During this golden era, it equipped 8 fighter squadrons. This was a massive footprint for naval aviation at the time. The Navy only began replacing these veterans in 1932. This happened when a new generation of aircraft like the Hawker Nimrod and Osprey entered service. But the legacy of this old fighter was undeniable. Hundreds of British pilots who would later fly in World War II logged their first hours at the controls of these Fairey biplanes. Fairey built the Flycatcher at its factory in Hayes, Middlesex, turning out around 192 production aircraft between 1922 and 1930. A typical carrier deployment saw 16 Flycatchers embarked, serving alongside 16 Blackburn Ripon torpedo bombers and 16 reconnaissance aircraft, as was the case aboard HMS Courageous. Across its long service life, well over 100 Flycatchers rotated through flights numbered 401, 402, 403, 405, and 406, along with 801 Squadron, keeping the Fleet Air Arm's presence sustained from the Mediterranean to the China Station. Pilots adored the type for how effortlessly it responded to the controls. One veteran aviator, Air Commodore G.J. Christopher Paul, later recalled that the Flycatcher was so responsive, a pilot seemed only to have to think of a maneuver for the aircraft to follow. It was in these nimble little fighters that the Fleet Air Arm first worked out combat tactics that would carry it through the Second World War. The phase-out that began in 1932 continued gradually. The type's last full carrier operations took place aboard HMS Glorious in 1933, and 406th Flight, among the last operational units still flying the type, gave up its final 2 Flycatchers in June of 1934, though a handful lingered in training roles into 1936. The Flycatcher was perfectly tailored for the harsh realities of carrier operations. Its compact size played a huge role. The wingspan of the biplane was just under 29.5 feet. To save even more space in cramped ship hangars, the wings could be quickly detached from the fuselage. In this dismantled configuration, the aircraft width dropped to just 13.5 feet. This made it incredibly easy to move around and stow. The Fairey Flycatcher stood out for its versatility. It could fly with standard wheeled landing gear or be fitted with floats for water operations. On February 19, 1924, at Northolt Aerodrome, renowned test pilot Norman Macmillan took the production floatplane version of the fighter to the skies for the very first time. Macmillan was among the most experienced test pilots of the era, having first learned to fly during the First World War before joining Fairey to put the company's newest designs through their paces. The aircraft was equipped with the flat-bottomed, boxy floats typical of the era, but the real engineering trick was that it had wheels built directly into the floats. This clever amphibious gear design had actually been patented way back in 1915. At the time, very similar floats were mounted on practically all seaplanes built by Short brothers. By the way, this was where the company founder, Richard Fairey, used to work. The secret to these floats was their shape. They tapered off sharply at the rear. Thanks to this specific aerodynamic and hydrodynamic design, the seaplane takeoff distance was significantly reduced. This allowed the heavy aircraft to get on the step and break free from the water much faster. In practice, though, this innovative hybrid of wheels and floats was far from perfect. Whenever the Flycatcher taxied across the hard surface of a normal airfield, it made an absolutely deafening racket. The hollow floats acted like massive resonators, much like the body of a giant double bass. This amplified the nasty screech of the steel tail skids scraping against the tarmac. Things were not much better on the water. The wheels sticking out of the floats created extra hydrodynamic drag. This made accelerating and taking off noticeably harder. On top of that, the wooden floats, even though they were skinned in varnished plywood, soaked up water pretty quickly. This meant the airplane would take on dead weight. As a result, its flight performance degraded rapidly. Early production models also suffered from much more serious handling issues. While picking up speed on the water, even on a perfectly calm and windless day, the seaplane would dangerously porpoise and bounce across the surface. To solve this problem once and for all, the British Air Ministry issued a strict order to ditch the wood entirely and equip the fighters with modern floats made from lightweight duralumin. Comparative trials of the updated design began in April 1926 at the Felixstowe test facility. The upgraded aircraft now planed across the water with a slight nose-up attitude. This allowed it to take off much faster and with far more predictability. In the air, the aircraft maintained its excellent stability. The seaplane was equally capable in aerobatics, easily holding its own against the landplane variant. The military found the fighter's maneuverability entirely satisfactory. Oddly enough, the new metal floats looked larger and bulkier than the old ones. However, they were actually significantly lighter. And best of all, they did not absorb any water. Following these successful tests, wooden floats were abandoned for good. By the late 1920s, the carrier-based variant of the Flycatcher officially became the Mark I. At the same time, the specialized floatplane version designed for shipboard catapult launches was designated the Mark I-C. This unique seaplane racked up an unusual operational history. For instance, test pilots used the aircraft to perfect an extreme takeoff method known as the slip flight. The launch crew would physically hold the aircraft back with quick release lines, while the pilot ran the engine up to maximum RPM. On signal, the lines were released and the fighter practically shot off the deck. Thanks to its incredible thrust-to-weight ratio, the fighter needed virtually no takeoff roll. Incredibly, they managed to perform this highly risky operation directly from the carrier's cramped lower hangar deck. This space offered barely 65 feet of run. Carrier landings at the dawn of naval aviation were treacherous. Until 1926, aircraft relied on devices known as Brierley anchors for braking. These axle-mounted hooks were designed to catch wires stretched across the deck. In theory, it made sense, but in practice, the sudden deceleration caused aircraft to nose over far too often. As a result, these dangerous anchors were completely abandoned in favor of standard wheel brakes. Eventually, engineers adopted a much more modern system and arresting gear with a tailhook. The very first aircraft to successfully test this revolutionary gear was the familiar Flycatcher biplane. The aircraft truly made its mark on naval aviation history in late November 1929. It was then that it completed the first ever night landing on the deck of the aircraft carrier HMS Courageous. Originating from a land-based airfield in Malta, the historic flight ended with a perfect touchdown in pitch darkness. The Flycatcher seaplane was so remarkably fast that it even served as a trainer for the prestigious Schneider Trophy races in 1929. To simulate race conditions as closely as possible, engineers fitted one of the airframes with high-speed floats. These were borrowed from a genuine Schneider Trophy racer. This allowed the pilots to hone their high-speed flying skills. The first combat unit to receive these brand-new fighters was 402 Flight. Its pilots had previously been flying heavily outdated Newport Nightjars. This made the transition a massive leap forward. By the spring of 1924, the new seaplanes had entered service with 5 additional squadrons. During this period, all ship-based aviation was reorganized under the Fleet Air Arm. This era also saw the introduction of individual aircraft markings. Flight Leader's aircraft featured special roundels alongside bright longitudinal and transverse fuselage stripes. These were supplemented by standard recognition markings. All Fleet Air Arm units were geographically divided into 3 major commands. These were the Home Fleet, the Mediterranean Fleet, and the China Station. Interestingly enough, it was in Asia where the Flycatcher floatplanes served the longest, right up until 1934. There, they flew highly unusual and dangerous missions. These included patrolling the waters near Hong Kong and hunting down pirates. The British pilots were so successful that their strike sent several pirate sailing vessels straight to the bottom. The Flycatcher's service record includes at least one act of remarkable improvised heroism. In 1929, Flying Officer P.D. Craycroft was flying with 405 Flight from the deck of HMS Glorious when he spotted from the air a division of destroyers steaming through dense sea fog directly toward another formation on the far side of the fog bank. His aircraft carried no radio, leaving him no ordinary way to warn the ships of the impending collision. Rather than watch disaster unfold, Craycroft deliberately ditched his Flycatcher in the water directly alongside the endangered flotilla, sacrificing his own aircraft simply to draw the crew's attention to the danger ahead. Flying the Flycatcher biplane was not for just anyone. Its pilots were rightfully considered the true elite of naval aviation. To show off their skills, they often put on thrilling flying displays for foreign delegations. Naturally, this served as fantastic real-world advertising for both Fairey and Armstrong. Thanks to these spectacular shows, Armstrong secured some highly lucrative contracts. First, they sold their powerful Jaguar engines to Poland and Czechoslovakia. Later, they even sold the manufacturing rights to those countries. The next step in the evolution of the aircraft was supposed to be the Flycatcher II. The first prototype was built for the Royal Navy in 1926. On October 4th of that same year, Fairey test pilot Norman Macmillan took this completely new design to the skies for its maiden flight. It was a sleek biplane with a cigar-shaped fuselage. The airframe featured a welded steel tube construction. Meanwhile, the tapered wings were made entirely of wood and covered in aircraft fabric. On the outside, the Flycatcher II looked almost nothing like its predecessor. The only shared element was its distinctive radial engine. In the spring of 1928, engineers rolled out a second prototype. This time, it was equipped with floats. It was powered by a Mercury 2A engine. This engine put out a solid 480 horsepower. To help reduce drag, the engine was neatly enclosed in a cowling. This aerodynamic improvement significantly boosted the top speed of the aircraft. The armament remained standard, carrying over from the previous model. It included 2 machine guns and racks for 4 bombs. Despite all these improvements, the project never made it into full production. The aircraft met an unfortunate end in 1929. All the prototypes were simply scrapped. Under the skin, the classic Fairey Flycatcher was a single-seat, single-engine aircraft with a mixed construction airframe. This aircraft was a true all-rounder. It could be configured as a floatplane, an amphibian, or a standard land-based fighter. What is more, the designers made it easy to swap out the floats for conventional wheeled landing gear. The wings of this biplane were built using advanced yet proven technology for the time. They featured an all-wood glued construction with twin spars. They also had a reinforced leading edge and a fabric covering. Notably, massive ailerons took up a third of the surface area of each wing. During landing, these effectively doubled as flaps. This helped the aircraft bleed off speed and safely touch down on the carrier deck. This camber changing mechanism, known within Fairey as the patent camber gear, was not an entirely new idea for the company. It had first been developed for the Hamble Baby, a modified derivative of the wartime Sopwith Baby seaplane that Fairey built under license during the First World War. Building on lessons learned from the Hamble Baby, Fairey then developed the Pintail, a fighter reconnaissance amphibian whose wheeled undercarriage folded up into the floats. The Pintail effectively served as a direct ancestor to the Flycatcher's own amphibious layout. Looking at the aircraft from above, both the upper and lower wings had a straight profile with neatly rounded tips. The upper wing was mounted to the fuselage using 4 cabin struts. On top of that, right in the center section, engineers built in 4 hoisting points. This made it easy to lift and move the aircraft with a crane. The lower wings were attached to 2 sturdy steel fittings on either side of the fuselage. Right at the root of the lower wing, the skin was reinforced. This allowed the pilot to safely step on it while climbing into the cockpit. This exact same reinforcement was applied around the flap hinges. The wings were connected by metal end struts. These were highly streamlined to reduce aerodynamic drag in flight. A pitot tube was mounted on the right strut. To keep the entire biplane cell rigid and prevent any flexing or twisting, the designers used duralumin bracing strips. These effectively tied the wings together and secured them firmly to the fuselage. The ailerons were operated by a simple cable system running directly from the control stick in the cockpit. The fuselage was built in 3 separate sections. The primary joint connecting these sections was located right behind the cockpit. The forward section of the fuselage had an oval cross-section. Its frame was constructed from welded steel tubing and skinned with lightweight duralumin panels. To make getting into the cockpit a bit easier for the pilot, drop-down doors were added on both the left and right sides of the forward fuselage. Inside the cockpit, the pilot sat in a solid steel seat. This seat was upholstered in genuine leather for extra comfort. The instrument panel was pretty compact. It featured only the bare minimum of flight instruments needed to fly the aircraft. The machine gun ammunition boxes were also mounted directly in front of the pilot. The original windscreen was a curved one-piece celluloid design. However, engineers eventually noticed that this setup caused severe optical distortion. So, on later versions, it was replaced with a 3-piece design made of flat, transparent panels. Immediately aft of the cockpit, the fuselage cross-section shifted dramatically. It transitioned into an inverted U-shape. The designers decided to build the aft fuselage out of wood. They framed it with rectangular wooden longerons. To keep the tail section from tearing apart under aerodynamic loads, this entire wooden structure was heavily braced. It used internal steel tension wires for this purpose. The outside of the tail section was then simply covered in aircraft fabric. The empennage was built using the exact same principles as the wings. The internal structural components were made of wood, and the outer skin was fabric. A complex system of tensioned rigging wires gave the tail the strength it needed. The pilot controlled the elevators and rudder using a conventional cable system. Notably, the incidence angle of the horizontal stabilizer could be adjusted in flight. It could be set between 2 and 4 degrees. This gave the pilot much better pitch trim control. The stabilizer itself was firmly braced to the fuselage using 4 sturdy struts. As a naval fighter, 2 different landing gear configurations were developed for it. The first was a standard twin float arrangement. The second was a hybrid amphibious version. The amphibious model featured large rectangular floats with small skegs at the rear. The undercarriage design itself was inherited from the earlier Fairey 3D, with radius rods running from the base of the oleo legs to the apex of an inverted V-strut arrangement. Later production aircraft also received hydraulic brakes, a notable improvement over the crude braking methods used during the type's earliest carrier trials. Additionally, main wheels were built right into the floats. When the aircraft was taking off or landing on water, these wheels remained semi-submerged. To prevent water from flooding the floats, the wheel wells were sealed off with watertight bulkheads. The floatplane variant specifically came equipped with lightweight duralumin floats. These had a hydrodynamic step built into the bottom. This helped the aircraft plane across the water much better. Small water rudders were mounted at the stern of each float. The pilot controlled these via the rudder pedals right from the cockpit. This made it much easier to taxi on the water surface. Finally, whenever ground crews needed to move the aircraft across the ground, removable beaching gear could easily be attached to the floats. The heart of the aircraft was a 14-cylinder Armstrong Siddeley radial engine. Specifically, it used either the Jaguar 3 or the Jaguar 6. This engine produced a solid 450 horsepower. With this power plant, the Flycatcher could reach speeds of around 133 miles per hour and cruise out to a range of roughly 310 miles. Its service ceiling was rated at 19,000 feet, and the aircraft could climb to 10,000 feet in well under 10 minutes, an impressively brisk rate of climb for a naval fighter of its day. Up front sat a large two-blade propeller. This propeller measured 9.5 feet in diameter. Early on, these were carved from solid wood, but on later production runs, they transitioned to more reliable metal props. To improve aerodynamics, the designers included a large propeller spinner. In operational service, however, mechanics usually just left it off. This made accessing the engine for maintenance and repairs a whole lot faster and easier. Fuel was stored in a main tank tucked deep inside the aircraft fuselage. This tank held roughly 64 imperial gallons of petrol, a bit more than 77 US gallons. Right below it sat a smaller oil tank, holding about 8 imperial gallons. As for armament, this naval fighter packed a solid punch for its day. Mounted on either side of the fuselage were two Vickers Mark I .303 caliber machine guns. These guns were synchronized to fire directly through the arc of the spinning propeller, a mechanical solution that had become standard practice across British fighters by the 1920s. To help the pilot aim accurately, a state-of-the-art reflector sight was installed right in front of the windshield. And if the mission ever called for striking surface targets, there were 4 bomb racks under the fuselage. They could be loaded up with 20-pound bombs. No original Flycatcher survives today. The Fleet Air Arm Museum at Yeovilton commissioned a faithful flying replica, registered Golf Bravo Echo Yankee Bravo, completed in 1977. This reproduction remained airworthy and flew regularly at air shows until 1996, when it was retired to static display. It remains part of the museum's reserve collection today, a tangible link to the aircraft that trained an entire generation of British naval aviators.